Did you know there's a material more conductive than copper, as flexible as rubber, harder and lighter than diamond, and is 100% real? It's called graphene. Graphene, a pair of carbon atoms that resembles honeycombs, is the building block of all graphite. Graphite, the main component of a pencil lead, is a crumbly substance that represents a layer cake of weakly bonded graphene sheets. Since 1859, scientists have been using complex experiments to try to find graphene, but the first crystals of graphene were discovered in 2004 using a very simple and effective method: ordinary Scotch tape. One evening in Manchester, two Russian scientists noticed small bits of graphene on the tape they used to clean a graphite stone. The two scientists, Andrei Geim and Konstantin Novosel, were awarded the Nobel Prize in Physics 2010 for their simple but groundbreaking experiments. Thanks to the Scotch tape method, this area of science has grown very rapidly. Now, hundreds of laboratories across the globe deal with different aspects of graphene research. What makes graphene a really super material is the combination of its unique properties. Graphene is the first 2D crystal known to us, the thinnest material ever obtained, and also one of the lightest. This is because it's 1 atom thick, so thin it would take 3 million layers just to equal the width of 1 pencil tip. Despite being one of the world's lightest materials, it's also one of the strongest. Graphene is harder than diamond and about 300 times stronger than steel. Graphene also conducts electricity and heat much better than any known material. Graphene is also a transparent material. Graphene is also very flexible and can take any form you want. Graphene allows nothing to pass through it except water. Graphene is even biodegradable. So how can the unique qualities of graphene help the world we live in today? Imagine flexible cell phones, a TV as thin as wallpaper that we could roll up and take with us, stronger but lighter aircraft that uses less fuel, smaller but faster computer chips. What if we replace the batteries in our electronics with supercapacitors made out of graphene? Now you're asking, what's wrong with batteries? Crappy. They run out of juice, they die, they overheat, they take forever to charge, and frankly, they're environmentally disastrous. A capacitor is different from a battery. A battery uses a chemical reaction to produce a stream of electrons. It's a lot of work for not a lot of payoff. A capacitor, on the other hand, cuts out that chemical middleman completely and simply holds onto the electrons until you need it. A supercapacitor does that even more so. After only a few seconds of charging, researchers were able to use a graphene supercapacitor to power a light bulb for minutes. Just 1% of graphene in plastic can make it conductive. Graphene could also be an anti-corrosion coating that is thinner, transparent, and longer lasting than anything that currently exists. But its most important use may be in the future of clean drinking water. Graphene's ability to let nothing pass through it except for H2O makes it the world's greatest filter. Graphene could cheaply and easily remove salt from seawater, potentially turning the world's oceans into vast supplies of clean drinking water for thirsty populations. And don't worry about running out of graphene. Carbon is one of the universe's most abundant elements. With this wonder material getting so much attention from scientists and researchers around the globe, it may not be long before graphene-equipped products find their way into stores near you.